Hi everyone, it's Dr. Beal again, and this is Alice the bird. She is super spunky because the sunlight is increasing and she's getting a little broody. So I don't know how long she's going to stick with us today, but she's here to talk about the human population, which is her area of speciality, I guess. We're going to talk two different videos about how the human population grows, and then also think about some of the considerations where we're not sparrows and we're not cockatiels. We actually are aware of the consequences of our growth, and how do we address that. Your discussion this week is taking that to the next level. You should watch these before you do the discussion posts, but I'm going to ask you to read about one of the books that kind of truly changed the world, and probably not for the best, called The Population Bomb, and then the consequences of that and what we think about that today. So the description for the discussion is a little bit different. You're going to read and watch the videos and then address all the questions. But when you do the responses, you're only responding to each person's 3, 6, and 8, I think. I highlighted them. So you're not responding to everything they say, but just the ones that are opinion-based and thought-based. So as you take a stab at that, let me know if that's confusing, because I don't think you need to respond to their definitions. So let's get started. Let's talk about the human population. So we've talked about this a couple times. The Earth supports about right now 8.2 to 8.3. I'm going to send you to look at the actual counter that we estimate the population right now, but it's increasing. As it increases, the growth rate has been dropping. So what that means is that as more and more people are born on Earth, the speed that we are adding new people is not astronomically increasing, but it's actually slowing down. The population doubled between 1959 and 1999, and that was a huge doubling from about 4 to almost 8 billion people. But today, the doubling rate is spread much further apart. In the same period of time, so another 50 years, from 1997 until 2037, we only think we will add half again as many people, not double them. So that's going to be a significant leveling off. I took a lot of these diagrams from either your textbook or from Our World in Data. Our World in Data is a wonderful resource for you as you come and start looking at your paper options. I'll respond to those and discuss them with you because they look really good. But Our World in Data is a place where you can find syntheses of lots of the data that you might be interested in for your papers and for your arguments. We talked about in the last set of videos the carrying capacity, sort of the limit that is set for the number of individuals in a population that an area can sustain. What sets our carrying capacity as humans? Those things, those resources that set our carrying capacity, food, water, access to healthy environments, lack or avoiding or treating disease, those things were really supplemented, aided by the development of 3 major technologies. Early agriculture, about 2000 BCE, where people started moving from a foraging lifestyle into an agricultural society and cities started to develop. That seemed to be a trigger to supporting more people. We could have higher access to food. The development of technologies like fossil fuels and the ability to do manufacturing, the Ford processing plant type manufacturing, really did increase the ability of people to live together in cities, but also the support technology that makes our lives healthier, easier, and less of a wear and tear on our bodies. Add to that advances in sanitation, no longer having open sewers, having access to health care like antibiotics and treatments in hospitals. Those things each contribute to supporting more people on planet Earth. We think that there's about 8, we're right about here, and this data, I like this chart, but this data is a little bit old. I like this chart because it shows the growth of the number of people in the human population compared to the rate of growth, which is this red line. The rate of growth is the speed that we are adding new people. And you can see since about the end of the baby boom, so this is the last of the baby boomers, we've been decreasing our rate, or the speed that we're adding people worldwide. If I look at the human population growth chart in a slightly different way, this one has the major events that we think have changed carrying capacity. The agricultural revolution back here, maybe I set a date that was a little bit too late, but that's the advent of agriculture. Things like the invention of the plow, that's actually not just hand digging rows, writing, spreading information, mathematics. The second agricultural revolution is really mass farming, the industrial revolution. And you see that what has happened as population has increased really rapidly since the mid-1900s is what has happened is we've had a lot of events that really do increase the carrying capacity of people on Earth. For most of human history, the population grew really slowly. There was a little bit of growth, but then on average about 1 billion people have existed on Earth or less since the beginning of time. There was a point in time where there was only 5 million people on Earth. We've definitely increased from there. If you look at, and I spread this back, even if I spread it back in time, we have a pretty level number of people on Earth for most of human existence. But recently, with the advent of really health, agricultural, and other technologies, the growth of people really starts looking like that J-shaped curve. An average of 249,000 new people are born every day. That's a lot, but that's fewer than were being born, or a lower rate than were being born 50 years ago. What does this tell you about the availability of resources when you see a J-shaped curve? The human population growth is not evenly distributed worldwide. Every country, every area of land is not getting the same number of people every day. That's obviously distributed in different ways around the planet. People also tend to move right now from rural areas where there's farming as the main industry into areas that are less rural or urban or suburban. I think if you live in Camden County, you're probably living in a suburban, urban environment. There's few parts of New Jersey that are rural. If you're living in Salem County, you might be living in a more rural environment. By 2018, 55%, this is the world population, not the U.S. population, 55% of the world population lives in urban areas. That means most people are living in cities. And that's because that's where the jobs are and the other people are that you want to meet and make beautiful babies with. All of that is happening in the cities. And that's where most of the population growth is occurring as well. When we look at, I'm going to change this chart a little bit. When we look at growth around the world, we see this is showing human population growth by political boundaries. You'll see that the human population growth is not evenly distributed. There's more people on the east coast of the United States than in the Midwest. There's more people increasing in India, parts of China, and Southeast Asia. There's a lot of concentration of people in Northern Europe. We can grow this population unevenly because these are where the resources are and where the technology is to support that number of people. Sub-Saharan Africa does not have huge crowds of people in it for the very, very reason that there's fewer resources. Those fewer resources, we'll talk a little bit in the next couple of videos too. Those fewer resources also mean a little bit more instability in those regions. Advances in food production and healthcare have paced the growth of humans around the planet. Life is actually a little bit better, and in some cases a lot better than it was in 1950 for the average person. We have access to more quality food, higher types of food, easier access to that food. The fact that you can DoorDash anything to your house is pretty freaking amazing, actually. You can go to the grocery store and there's almost always groceries there. Those advances mean that we can support a lot of people in an urban environment, and that's good. What about the degradation of natural capital, though, as those people increase? So what about the environmental impact of increasing number of people? the question becomes, how long can we actually support this number of people on planet Earth and an increasing growing population? And some of this I am leaving deliberately vague because I'm going to ask you to think about it as part of your discussion. Again, those discussions would be, if we were in person, what we would do next after this lecture. You would delve into it and discuss it. So treat it that way. If we were in person, we'd be having this face-to-face discussion about these topics. You will find as you go through the readings that I gave you, which are brief, and the video, which is about 10 minutes long, that a lot of people already think we have exceeded the tipping point of how many people the Earth can support. But other people think we have not. I'm not going to give you, I actually don't have an answer to that. I'm not going to give you a final answer on that. I am going to say that the main problem we have is making sure that the people that are here have access to a quality of life that is sustainable and also nice. You don't want to be a subsistence farmer scratching the dirt for a bean, but you also, don't want to destroy your environment so that you have access to all of the things that you've ever dreamed of. There's a balance there. And trying to reach that with billions of people on Earth is tricky. Some people think that the main problem with what is happening on Earth is the overconsumption of rich countries and wealthy countries compared to poor countries. If everybody lived like people did in the lowest impact countries, our impact on Earth would be a lot different. Some people figure that technology is going to solve it all, and that as the problems of the growing population become apparent, that technology will deal with it. And to be fair, it has in the past. But whether that population is increasing because the technology has changed, or the technology changes and therefore the population increases, I don't have an answer for you today. I do know that as the population grows, our ecological footprint as a human species grows. And the ecological footprint, we're going to look at it after spring break. I'm going to have you analyze your footprint. That is your and the human species' impact on the entire planet and its natural capital in a sustainable or an unsustainable way. We affect the population size, and we talk about how many people can we support. But your book, and I think it does a really nice job in talking about that that's pretty much the wrong question to ask. And I agree that we don't want to know how many people can we squish on the planet. We want to know how many people can live well on the planet. And so instead of asking about the carrying capacity of people, we should ask about the cultural carrying capacity of people. How can we as humans live well and sustainably in reasonable comfort, in reasonable freedom, indefinitely? So our children, children's children, and our great-great-grandchildren, without degrading the earth so that it impacts future generations. This is a list from the text of ways that humans in general degrade natural capital, degrade the environment around us and the things that we actually need to live on the planet. We've been talking about the reduction or the maintenance of biodiversity. We've talked about the fact that primary productivity, the amount of photosynthesis going on the planet, is incredibly important for supporting really diverse food webs. We've looked a little bit at genetic diversity. Really, it's a kind of a different class. If you want to go really in depth to it, there's genetics. You've already taken Bio 1, so you talked a little bit about genetic diversity and how that becomes the fodder for natural selection. But when we do other things like eliminate predators because we compete with them and we're the biggest, baddest predator out there, we get rid of our competing predators, we introduce harmful species to different communities and invasive species, and I have more coming up on invasive species for you. We also, after spring break, will start talking about the use of renewable versus non-renewable, building new infrastructure, disrupting those biogeochemical cycles and relying on non-sustainable, non-renewable fuels. These things all have an impact, and the more people that are doing those kind of impacts, the more damage our society has. It doesn't mean we have to do these things. We don't die if we don't do these things. This is just how we live right now. I want to talk a little bit about how our population grows and shrinks. We talk about fertility rates when we account for predicting the growth of future populations. Fertility rates are really about predicting how many people are going to be born in the future. And we have to consider the fact that populations grow and shrink and stay the same over time. The number of children born on average per woman, however, is the way that we guess what is going to happen in the future. And that's the total fertility rate. We use number of children per woman because it's easier to trace if a woman has a baby than if men have a baby. And frankly, women are more confined to having fewer children. You can have one every 10 or 11 months. I don't recommend that. That is really hard on your body. But you could have a baby every year for your fertile range. That could be 20 babies. That's a lot of babies. But men, because they're giving sperm and not containing the baby inside of them, could feasibly have hundreds of babies or none. And it's harder to track. So we use number of children born to a woman in a population on average as the average fertility rate. The crude birth rate, I changed the words. The crude birth weight is the number of live births per 1,000 people in a population per year. The crude death rate is the number of deaths in 1,000 people in a population per year. And then population change is really births and immigration, people coming into a population, minus deaths and emigration. Then we can estimate population change. This is exactly the same as the last lecture, except now we're not going to worry so much about controlling the evolution of types of lifestyles. We're not semoparous versus heteroparous. This is just talking about humans in different countries. So the rest of the variables are all held the same because we're all human. When we talk about a replacement level fertility rate, the number of children a couple must have to replace themselves in the population is, you probably thinking it should be 2, because one parent and another parent, in order to replace themselves, have to replace themselves with 2 children. But because of mortality and children dying or not reproducing as they age, that number is more about 2.1. And so on this chart here, you can see this dark line is marking the replacement level. You can see and I want to talk about the baby boom, which was predominantly in other places, but I want to talk about it in the U.S. because it has flavored our population makeup so strongly, especially now, I guess since the 1940s. You could see that the number of children being born between 1946 and 1964 was well above the replacement level, only an average of almost 4 births per woman. By the 1970s, that drops below replacement level, and we have in the U.S. stayed below replacement level at about 1.8 since then, which is why there are so many baby boomers and so few of the rest of us. I'm not a boomer. The total fertility rate is the average number of children born to women of childbearing age. I think that these may get confused in your head. Replacement is replacing yourself. Your total fertility is how many babies do everybody actually make. If I want to stop populations from growing, the total fertility rate of the entire planet has to drop to the replacement level. And that way everybody would just replace themselves and we'd be at what's called zero population growth, or ZPG. This is where the population is neither increasing nor decreasing, but holding steady. Which sounds nice, but we're going to talk about some of the problems with that. Human population size estimated in 2050 is between 7, this is less than we have today, and a bit more, 10 billion. So we'll either go down a little bit, and a little bit, we're losing 500 million people, or up a little bit, we're gaining 1.5-ish billion people. The ranges between these are because of different modeling types. So we don't know what's going to happen And frankly, it's unethical for me to force people to have or not have babies to test my experimental data. So what we have is a series of models that we use to model fertility rate worldwide. For right here, these models are all really, really close for 2020 because that data is, when these data were collected, that data was about to be real. We were collecting very real data here and estimating just a year or two into the future. The further in the future we have to measure and estimate, the more the range of possible highs and lows are, because I have more error the further in the future I'm trying to predict. I want you to look at this here and maybe pause it here because it's going to ask you a question in a couple seconds about reading this chart. And I think you'll still be able to see the chart, but I'm not 100% sure. I think it puts a box up in the middle. The estimate range here is somewhere 10.8 to 8.7.5 or 7.8. What are the ranges for 2040 and for 2030? So I'll give a second, and then I'm going to pop up that question in a question box, if I time it right. The total fertility rate, the TFR, in the United States has fluctuated from a high during the baby boom, the height of the baby boom, to about 1.8 today. So if you're having children right now, you're having children at a rate that is below the replacement rate. But our population is still growing. Because there are so many individual humans making humans, we still have a lot of people coming in being born. But a huge amount of our population increase in the United States, and now I am going to zoom in on the United States, a huge amount of our population growth is through immigration. In fact, our population from births should be shrinking, but almost 40% of that population increase in 2015 and beyond has come from legal immigration. So right now, the U.S. is one of the top destinations for people around the world to immigrate to, for jobs, for technology jobs, for education. Despite everything that you are seeing in the news, it's still a place that a lot of people want to come to. Northern Europe, and I do have, as we go through, I think I have it here. No, I have it in a couple slides. I took a picture of today of all of the immigration routes and the most likely percentage of people coming in and immigrating. Right now, a huge percentage of the population of people coming into the U.S. are coming from China, India, and still a lot of people from Mexico. This is, I'm going to ask you, I don't want to ruin the discussion. I'm going to ask you in the discussion, is that good or bad? Think about it from the fact that you, as an aging population, and it will happen to you someday, will need people to care for you and take care of you. If we don't have enough people being born to be the youth that is taking care of people that are aging, and no one is coming in establishing new families, and there's no one to take care of you, you have a problem with an aging population and no support and no structural support for the economy or the infrastructure that are supporting the population that actually lives here. Population is growing due to immigration, and frankly, huge changes have occurred in our standard of living in the last 50 years. Heck, I would say in the last 20 years. A huge difference in how our lives actually work. Accessibility to healthcare, accessibility to travel, accessibility to information. All of those things have boomed. And sort of how we have access to so many resources all the time. The U.S., we're going to look at it, and the U.S. and New Jersey, and then we'll compare it to the world. We use a lot of stuff. A lot. Way more than most places in the world. And that's reflected in our increasing quality of life. The life expectancy in the last 100 years has almost doubled. The women being able to work outside of the home and have an education is astronomically different. The advent of things like Title IX in the 1970s and 80s, and the enforcement of those has really, and I guess really into the 90s, has really opened up the workforce for women, particularly the medical and research areas. The number of high school graduates in the U.S. is astronomically larger, and college graduates. But, fun things to look at here. Almost everybody has a toilet now and electricity. Whereas not even 100 years ago, those two things would not be something you would necessarily have in your home. This hourly manufacturing job wage, I'm a little incredulous. I think they're not taking inflation in there. Here, too, I want to note the murder rate in the U.S. has also dropped significantly in the last 50 to 75 years. What do you think has a bigger impact on our footprint on the world? The increasing population growth or the impact of developing new technologies and new higher quality of life? And I'm not going to stop and ask a question here as part of this. This is something I'm going to ask you to think about for your discussion. Factors that really affect birth and fertility rates. Two things. The importance of children several things. The importance of children in the labor force. And so think about, you're probably like, what is their importance? It's almost nothing in the U.S. today. Most children do not work as small children, but 100 years ago, many children under the age of 6 were working full-time. The cost of raising and educating children is very, very high right now, but we also have a lot of opportunity for them to get more successful than their parents. The availability of pension systems, things like your Social Security, your Medicare and Medicaid also supporting people, those things and the stability of those affect fertility rates and birth rates across the country and across the world when they're available. Access to urbanization, access to education and employment for women, the average age where women have their first child. If you have your first child at 12, your children will be adults and having their own children by the time you are 24 or 25 years old. That's very different than waiting until you're 30 to have children. If your children follow in your footsteps, now you're 60. In the first case, you could be a great-great-great-great-grandma by the time you're 60. In the second case, you're a grandma by the time you're 60. And that's way fewer people in that second case. But also we know that spacing out and delaying to have children also improves the life of women and children in every single case. And frankly, their communities and their families and the men in their lives as well. It's more stable, and you have an opportunity to build your own stability before you're trying to take care of children. Religious beliefs, cultural norms, traditions also play a big role in birth and fertility rates worldwide. Life expectancy is an indicator of overall health of the people in the country. If your average life expectancy is 40, I think that life is hard and unpredictable, and you probably don't have access to reliable health care. If your average life expectancy is 80 years old, where it is in New Jersey right now, the average life expectancy of women is like 82 and men is about 80, 79, 80. That life expectancy makes me think you have access to regular, at least predictable food, jobs, and health care. Infant mortality rate is something else we look at. It's fairly high in the U.S. compared to other Western countries. It's much lower in the U.S. than it is compared to undeveloped countries where they don't have as easy access to health care. That means it's more difficult to get to the hospital. In New Jersey, there's really a hospital pretty much everywhere you look. Most places in the world that is not true. And certainly in places where you might travel a day or two to healthcare, it's not worth it to go there for prenatal or childbirth care. Infant mortality is caused by a lack of early childhood health care, insufficient food, improper nutrition, and an inability to control infectious diseases. Malaria is still the biggest killer of children under 5 worldwide, but diarrheal diseases that cause diarrhea, are also way, 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 way up there. Those are often caused by no access to clean and filtered water and other things. Migration. This is a map. I thought I'd put it earlier. The migration of people in and out of specific areas affects population rates and also decreases the population of places they are leaving from and increases the population of places they are going to. People immigrate for various reasons. It could be for a job or improvement economically. It could be to avoid religious or persecution or armed conflict, political oppression, war, being bombed. And environmental refugees are also increasing as the ocean levels change and the environment becomes unlivable in some areas. Now to look at this is, if you click on this in the slides that you can download from the Canvas site, it'll take you to this map, and you can click through. This is a whole series of interactive maps about immigration. The squares are based on the population size. So this is a map of the world. This is the US and Canada. This is Mexico. This is Europe. This is Asia. I don't have my glasses on, but so I can't see what the labels are. Okay, it says Asia. Okay, China here, India, and then this is Australia and New Zealand, to give you a map here. This is showing the percent of people that are migrants or coming in from not being born in those countries, and you can see and click through on this. It'll actually, if you scroll down, it shows you the main migratory pathways. We're still drawing most of our population increase in the US from migration, and so is much of Northern Europe as well. With that, I'll wrap up video 1 and start video 2. Video 2 is about age structure, so how we look at the structure of a population today and predict the future, and a little bit about how we expect population growth to occur all over the country. Again, country and the world. Again, consider these as you answer your questions on the discussion. You can look at those questions now. I think that the tendency is to say more people bad or more people good. I would like to hear both sides of that argument from you. There are reasons why more people are good, and there are reasons why having too many people is bad. I want you to look from an environmental, but also a social and cultural and political point of view for answering those questions. I'll see you in the next video. I do have, if you have any trouble with your experiment, the snow is melting. It's Sunday, March 1st, the day I'm filming this. The snow is melting. I'm hoping if you have not been able to get to a lake, you need to get to a lake this week and start your ecological succession experiment so that you have enough time to finish it before the end of the class. We've certainly had a lot of snow. All right. I will see you in the next video. Bye-bye.